Alrighty, welcome and good afternoon, ladies and gentlemen. My name is Dirk Didascalou. I am responsible for the Internet of Things at Amazon Web Services. And it's my real honor to spend with you the next hour here at reInvent 2019 talking about the latest and greatest development around AWS IoT. And we have quite a few latest and greatest development because our teams spent quite a bunch of time developing new features for IoT over the last year. And therefore, I would like to bear with me that I give you a 200 level in introduction about all that we have launched over the last few weeks. And if you would like to get some more details, there are many more deep dives, chalk talks for the rest of the week so you can really dive deep in anything that we present, if that's okay for you. We typically start every single customer engagement at AWS for IoT with a single question. And it's like, if you knew the state of everything, of all of your assets, and you could reason on top of that data, what problems would you solve? And we make it our mission here at AWS IoT to make the two conditions, namely knowing the state of everything and asset, and being able to reason on top of that data, come true for all of our customers that they can solve their business problems. And our customers have very many business problems, and we also have quite a significant amount of customers now. We have tens of thousands of customers now using AWS IoT, solving their business problems. And those business problems go across a variety of different type of verticals. Whether you think about industrial processing like Fender, the famous guitar manufacturer, who's improving their wood processing for guitars. Or in energy, SolarNow, for example, who uses AWS IoT to remotely gain access for their solar farms. Or patient health with Philips Healthcare, which built their HealthSuite digital platform on top of AWS IoT. Or connected vehicles. I don't know whether you've been at the ARIA. If not, I highly encourage you there and see some of our expos. For example, there's this Karma car together with BlackBerry and Lixar, where you can see what we can do in the automotive space or in agriculture. For example, Bayer Crop is using AWS to reduce food waste in their crop processing, or safety with Module, which has the safety belts, or Wisecam in homes, or iRobot, or Visio and other companies who do stuff in the home space. So very broad applications of what you can do with IoT. And if you classify them, I'd love you to think about them in two ways. On the one hand, IoT helps you to grow your revenue, because now you can build new software, new services and products which you couldn't do beforehand. That's the right side of that picture. Think about the products I just talked about, Module, the safety belts, or everything which you were not able to do beforehand. And on the other side, you can also save cost for something that you have to do before. That's typically when you think about, okay, I want to have intelligent decision making, or I want to have optimization of all of my processes. So IoT really helps you on both sides of your business scale, increase revenue, more dollars earned, and less dollars spent for your OpEx and CapEx. And in order to make this work, I want to walk through you on the highest level about the three fundamentals of IoT. On the highest level, when you start from the bottom, it's about device software. The T in IoT, the things, of course, crucially important. You somehow need software that you can put on those devices, that you can build them and operate them at the edge, and that they can communicate and work with the cloud. Then you, of course, need services in the cloud to connect those devices. And the most important term here is at scale, and manage those fleets, keep those fleets healthy, and keep them secure. And last but not least, when you go to the top, it's all about the data that those devices deliver and sense for you, so that you can make sense out of the data and take actions for your businesses. But I don't want you to think about this like a layer structure where you have hardware on the top and go the software stack upwards. I rather want you to think about this like a circle, where you have devices that sense, sent via the control and connectivity service data into the cloud, where you then use analytics service to gain insights out of your devices, take actions which you bring back to the physical world, to the devices, which then can act in a more clever way, which at the same time then means that you have different sensing. So think about this like a virtuous cycle, which is rolling all the time and gives you the intelligence and outcome that you really want for your businesses. And AWS now has different type of service and software in all of these areas, and I will go through them one by one, starting with device software. And you could argue, okay, why does a cloud company bother and provide us with device software which is not even running in the cloud? And I always refer to there's the three laws, we just refer to the three laws because neither time nor advance in technology most likely will have an impact of them. And one is, sometimes you simply cannot upload data to the cloud because as long as Albert Einstein and physics are still there, if you don't have connectivity, there's no connectivity. And if you have latency-sensitive applications, then of course you can't afford a round trip to the cloud. So you need to have local processing. And very often it's also what we call the law of economics, too cumbersome and expensive for you to upload all the data to the cloud. And the reason is there because the generation of data is an explosion with no upper limits. However, transfer cost is bound, and the reason is because spectrum for transferring data is limited. The amount of data you generated is not. And last but not least, there's real regulation. There are laws which prohibit you to do certain things, or you just might have your own company regulation. So we call this the three laws, and therefore we need to make sure as AWS that in IoT you can run all of your workloads in a distributed manner. And the typical questions that you of course ask, typically when you are a device manufacturer in the beginning saying is, how can I build the devices that operate at the edge and can also work with the cloud? That are the additional sub-questions here. For example, one of them is, okay, now that I can actually have this device at the edge, how do I get all of these cloud capabilities working locally? That when I have applications built, they work even with intermittent or no connectivity. And last but not least, how can I make sure that the devices I build or use or buy actually work and do what they're supposed to do? And for all of these three questions, we have different type of software offerings because IoT is actually pretty complex. It spans from very small sensors running on microcontrollers to very sophisticated machinery and industrial gateways, all having very different type of workloads. For that, we offer, for example, the world's leading real-time operating system called FreeRTOS, which is installed on billions of devices and helps you to connect microcontroller-based devices, typically light bulbs. Every LED has a microcontroller in it, or thermostats, and do this in a secure way, and that you can update them and have the right protocols. And if you use different type of software, we have open source IoT device SDKs, which is again code, which is open and open source for you, so that you can put any other device with the same functionality, that you can control it and connect it to the cloud. If you have more powerful devices like gateways, that for example you have in your factories, and you would like to bring the cloud paradigms to the edge, there we offer what we call a software runtime AWS IoT Greengrass, which brings you all those capabilities to the edge so that you can work also in offline mode. And last but not least, we even offer you tools for testing that you can test it. I implement my FreeRTOS implementation correctly, or is my device actually configured in the right way that it can run IoT Greengrass? And I would like to go a little bit more into Greengrass because typically the question nowadays, okay, what do I do at the edge? What does edge processing actually mean? And we started with a service called IoT Greengrass because we wanted you to have the exact same software paradigms in writing your applications, whether you deploy apps in the cloud or at the edge or hybrid. So that means if you want to have your local devices on a local network connecting, you need to have local messaging. Greengrass provides you local messaging, the same topics that you have in the cloud. You want to take actions. And typically in the cloud nowadays, serverless, you use Lambda functions, so that's why you have a Lambda interpreter engine locally on Greengrass. You want to have data and state sync once connectivity gets on again, so that what you have done locally and in the cloud is also matched. You definitely need security, so Greengrass acts like a security authority for you. You want to have machine learning inferencing at the edge. You train in the cloud, you inference at the edge. You want to have access to your local resources, whether it's memory or specific sensors or cameras. You want to build connectors to local software services or other cloud services, and of course you want to keep it up to date. That's all the capabilities that Greengrass had so far. And just last week, we tackled and launched a few more capabilities. And one of the new capabilities answers the question here, which you see on the slide, because most of data generated at the edge from sensors comes actually in the form of streams or messages. So you will ask, okay, how do I now process this data coming from my rotating machine or from my sensors locally at the edge, and particularly knowing the constraints that you have at the edge devices? You don't have infinite compute and storage, so what do? And that's why we launched Stream Manager for IoT Greengrass, which helps you tackle exactly those problems. You can set policies what to do with your streams on an individual stream basis if your local memory runs out of space. What do? Do I do a ring buffer? Do I make first in, first out? You define that, Stream Manager does the rest. Then, if connectivity gets on and off again, which of my data that I process locally at the edge would I like to upload first? Most likely the process data. And when I have, let's say, lower connectivity, maybe then I can wait for some of my raw data. And last but not least, you want to upload all of this most likely into something like Kinesis in the edge, from the edge to the cloud, or in AWS IoT Analytics. That's all what the Stream Manager does for you. And one of the customers of ours who was the first to actually use Greengrass in GovCloud was Lockheed Martin, which you can see on the slides. And they built their local technology based on AWS IoT Greengrass. And they want now to use the Stream Manager for exactly that purpose, streaming all of this information coming from the different facilities into their cloud backend so that they can then optimize the local processes. And believe it or not, do things as simple as reducing paper waste when you have manual processes, because now that you can get all of this information in one place, you don't have to do this anymore. So that's a typical use case for Stream Manager. More and more of the companies who now embrace IoT actually have built their existing software on legacy application and code. And many of them also standardize on containers. And the question we get more and more is, okay, how can I deploy my containers to the edge? I get it that you have this serverless concept Lambda and that you can deploy machine learning inferencing at the edge. How about containers? And we're happy that we launched last week also now container support for Greengrass. Now you can deploy Lambda functions and Greengrass Docker containers on the very same device. You can package your applications in a typical standard Docker container format. You can deploy it, and whether you have the Lambda functions, containers, or ML inferencing, all of that can interwork, and you can get those container either from the Docker repositories of your choice or even from ECR, which is our Elastic Container Repository, or also the Docker Hub. And we allow you accessing this very securely because another capability that Greengrass already has is a secrets manager, so we make sure that your secrets are safe when you have to locally access those. So Docker container support. Another feature which AdLink, one of the leading edge computing companies, is using. So AdLink use Greengrass as the major deployment mechanisms of all of the applications on their gateways. And of course, now with Greengrass container support, all of their customers can now also deploy hand-in-hand all of the containers on these type of gateways. So I just gave you a little bit of insight of what were the additional new software capabilities, particularly in Greengrass, that we launched last week. Now, let's switch gears and go into what do we do on the service side. So on the server side, when you have your devices, and okay, they have the software, I found them, how do I connect them to the cloud? It's the first question. Securely connect them to the cloud, let them send message, and do that at scale. And the most important word that I used was scale, and I will come to that a little later. So managing really big fleets at scale, connecting them, keeping them secure is very important. The second question here is how do I keep those fleets then doing what they are supposed to do, means keep them healthy. And last but not least, how can I get them secured? And that's why we have launched over the years these three specific services. One is AWS IoT Core, our connectivity and data management service, if you like, device management for fleet health, and fleet operations, and IoT Device Defender, which audits your device fleets and for the security best practices, and also figures out whether there is something going wrong on your devices because it detects. And we always say at AWS we have two priority zeros. One is security. That's why we were very proud that IoT Device Defender actually won Best IoT Security Solution this year at the IoT Worlds Awards for its audit and detect capabilities. And the second priority zero, apart from security, always is operations. Operations and operations, particularly when you start connecting devices and handle the data they generate at mega scale. We have customers who not only connect hundreds of thousands or millions, but tens of millions of devices to our cloud. So we had to build AWS IoT Core that they now can handle hundreds of millions of devices and hundreds of billions of messages on your behalf. So very important. It does all of this connectivity via device gateway. It's just one of the features inside. The message broker is handling all of the message transferring for devices connected to the cloud amongst each other. It has all the authentication authorization built in. It has registry, device shadows, and rules engine. So all the typical stuff that you need when you start building. But what we realized is that one of the biggest hurdles of IoT stems from its biggest promise. IoT always claims, oh, you will have hundreds, and I even said this before, of millions of devices connected to the cloud. Try to connect to 100 million of devices and try to manufacture them first. The first thing that you figure is, oh, good, now I need to configure every single one of them. They need to get something like certificates. They need to figure out where to connect to. If you do this manually, that is an awful lot of work that you would have to do. But that's the biggest impediment for device manufacturers to get the devices connected. So therefore, we launched last week a new capability which we call fleet provisioning, which was based on the learnings of our own device making, namely the IoT buttons or third-party devices like we have with the AT&T and Soracom LTE button, so that you have a zero-touch provisioning at scale for all of your devices. And this is how it works. You define a template once in the cloud which you can apply to all of your devices. You can now produce a device with a generic certificate and a generic endpoint on this firmware. You don't have to know up front where do you want to deploy this device. And at first power on of the device, when it connects to AWS IoT, it gets automatically provisioned, it gets its unique certificate, all the other device-side provisioning, and all of the cloud-side provisioning in one go. And it can do that whether you direct connect it to the cloud, like for example with RF technology, or whether you have an intermediate gateway, like when you have a Wi-Fi device that you need to configure for Wi-Fi passwords or Bluetooth, because we both have the IoT device SDK enhanced as well as the mobile SDK to do that without any customers understanding that's happening in the back end. So a massive step, again, to enable scale of AWS IoT and AWS for our customers. In Hunter Industries, which is providing irrigation systems, like here for a golf club, they had exactly this problem. They had to figure out upfront when they manufactured all of the devices, how do I pre-provision them correctly? What is my logistic chain to control them? All of that is drastically simplified, and you can see the quote of their director of software development, because they can now build a generic flash software firmware for all of the devices, and all the rest happens by power on. Talking about scale, talking about companies who actually get now much more successful in IoT. When you start with a few tens, thousands, or hundreds of devices, everybody can do this by themselves. At least it seemed to be. What we have seen over the years now, particularly over the last 1 or 2, more and more of the customers come to us and said, oh, now we actually go to our scaling limits. Because our typical value add is either specific type of device or a specific vertical where we bring added value, but handling this infrastructure, going to millions and tens of millions of devices, really very difficult. So they ask us, what can we do as AWS to help you transform your existing brownfield deployments, put this on AWS so that you really make them scalable. And if you do so, very often there's rewrites in your software or even on your device code necessary because you have some legacy. And in order to make that work, we announced last week a new capability as well for IoT Core, which is called Configure Endpoints, and it has 2 specific features. One is custom domains, and one is called custom authorizers for MQTT connections. What that means is you don't have to update your device software anymore if it points to a specific domain. You don't have to use the more let's say, resource-intensive server certificates if your devices are constrained, because we trust your own trusted devices by bringing your own authentication. Massive easement of migrating existing applications and brownfield devices onto AWS so that we manage the scale for you. And one of those customers of ours is LG Electronics, and they don't only put the fancy, expensive equipment on the left side, they also have a ton of other appliances, many of them not having enough memory to handle these server-side certificates. And with custom endpoints and the custom domains and custom authorizer enhancements, they can now use their existing hardware without changes and connect them to the same platform which they built on AWS IoT. So it was all about scale. Switching gears a little bit, who of you has heard about Alexa? Anybody tried Alexa? You might even have some of devices in your home. I don't know, the smart plug in the home maybe that switches your light on and off, or the Amazon Basic microwave, or our smart ovens. By the way, all of those using Amazon FreeRTOS as the operating system IoT in the back end. But there's a class of devices which you call Alexa built-in. And Alexa built-in are those devices which you can directly talk to because they have a microphone and a speaker. So the Echo Auto, for example, is one of those. Put in your car, you can talk to it. And if you wanted to build, as a third party, an Alexa built-in device, it required quite some resources on your device for all of the audio processing. Now I'm using some gibberish technological terms, so it needs more than 100 megabyte of RAM. It typically uses a real microprocessor, typically Cortex-A type of devices, which increase the E-BOM, so the BOM, it's a bill of material, and make the devices more expensive. So we were thinking hard with some of our partners, how can we make those devices so much more cheaper? And last week we announced what is called AVS, that stands for Alexa Voice, Integration for IoT Core, which reduces the bill of material and therefore the cost for building Alexa built-in devices by 50%. And the magic which you put down here is that we offload all of the local processing to the cloud. All of the audio processing that you had to build in a device now can happen in the cloud. So, and the effect of this is instead of having 100 megabytes of RAM, you need 1. That's 2 orders of magnitude of reduction. Instead of using a microprocessor, you can use a microcontroller, which again is typically an order of magnitude in cost. And all of that we also speed up because we work with companies like NXP who have then pre-configured development board to make the development really easy. And speaking about the type of new devices you can enable, particular light switches, it is my pleasure to welcome on stage Sean Monteith, who is the CTO and VP of Engineering for iDevices, who can tell you what his company is doing with this type of technology for enhanced consumer experiences. Sean,
thank you.
Welcome.
Jeremy. So what does iDevices do as a company? And so I can simplify that. Just think of home automation. We make and develop connected devices like light switches, dimmers, thermostats, and also just a plain old light switch. So what kind of expertise is required for this? You need cloud architects, you need IoT visionaries, you need software architects, system architects, UI, UX, app development, hardware, software development. There's a lot of things that go on underneath the hood, and we've got to support other ecosystems as well. It works with Alexa. Our products work with Alexa. Apple HomeKit. Those are just a few. And so we're part of a bigger corporation, Hubbell Incorporated, located in Connecticut. We're located in Connecticut on the East Coast. And so there's a company, Hubbell Lighting, that's located in Greenville, South Carolina. And they do commercial lighting. They also do consumer lighting. Progress Lighting is one of those companies. And so the lighting, the trends that I'm talking about, they're really about commercial lighting. Some of the lighting in this room, retail, big box stores, lighting fixtures. That's what I'm talking about. So if you really think about the innovation that's gone on in light fixtures, it's been very limited. Yeah, there was a big push to go from incandescents to LEDs that was, really enhanced the power load. Yeah, innovation, but the intelligence isn't really there. There's no sensors. There's aux sensors really just for power efficiency and ambient light sensors for power efficiency. So we've been working with them. Just imagine a light fixture with computer vision. So a camera. Imagine a light sensor or a light fixture with a microphone. So now you can start to listen to emergency sounds like smoke detector, glass breakage, those types of things. And so really it's moving beyond just individual control, and it's the same parallel in home automation as well. ADR, automated demand response, that's really the utilities controlling the loads during peak power situations. In low voltage lighting, yeah, LEDs are low voltage by default, but really what I'm talking about here is there's an opportunity for buildings to be completely DC. So if you think of your LCD TV, it's got an AC to DC converter in it, so it's really DC under the hood. Same thing with your laptop. And so there's really an opportunity going forward to have complete DC buildings. And so what are we trying to do? What problem are we trying to solve? And so, like I said, with the light fixtures, there hasn't been a lot of innovation. Same thing with just plain old light switches, your granddad's light switch. There hasn't really been a lot of intelligence in there. Yeah, in the last 4 years, people have connected them, but there's really no intelligence. So yeah, what we're going to try and do is put some intelligence into the product. And so first, connect the light switch. Secondarily, we added Alexa built into the device, as Dirk talked about. So 2 microphones, there's a speaker in there, there's a speaker box, there's an LED ring, and if you look at that LED ring, it looks very much like an Echo device. And it's really, really challenging in that form factor. It's really small. It's just a paddle switch. It's a standard paddle switch on the wall. There's no holes in the product, so it's a challenge to get good sound quality out of there. And so what we were shooting for was like speakerphone quality from an iPhone 10. And so we've used partners, and I'll talk about who the partner is that we use for the silicon. We could do that ourselves. We have a lot of expertise, but it's going to take us 3 or 4 years. There's no reason in the world to go down that path and reinvent the wheel if it exists. Take advantage of those partners. And so that allowed us to focus on creating a premium product, on the microphone design, the speaker box, the speaker itself. And then really the real crux of this story is typically our design cycles are for anywhere from 12 to 18 months. We cut that down to 4 months. We started in March. We were manufacturing the product in June of this year. And so that was a major accomplishment by my team. So it's really just the trade-off between make versus buy. Why reinvent the wheel if it's already there? So the partner that we chose for silicon was NXP. Dirk talked a little bit about some of the solutions that they're providing. First of all, it needed to be AVS certified. I was not going to be a guinea pig. It had to be certified. It uses Amazon free RTOS, really important to us. And it connects to AWS IoT Core. And the second part of this equation is really what Dirk talked about. There's a lighter protocol out there for AVS. As soon as you start to use or create third-party devices for voice services, it's usually Linux-based, it's multi-core, it's very, very expensive. And so the other thing with IoT, performance and scalability and analytics. And we've done our own cloud, we use AWS IoT. But to put those tools around there and really determine how good the fleet is doing, it's really difficult. And all those tools, the data pipelines are there for us to do that and make sure that the devices are operating properly. And so this is a product that I'm really, really proud of. I got to give kudos to the team back in Connecticut. To get something out in 4 months is a real challenge. Sometimes just getting a resistor change in a product takes you 6 months. And so this is by far the most successful product we've ever launched. If you want to see this firsthand, I would recommend that you go to the Quad, go to the Connected Home, and look at it. There's 4 or 5 Instinct devices in there. It's pretty loud, but I assure you, if you buy this product, you take it home, it's going to pick up your voice 40, 50, 60 feet away. And I got to thank Dirk for, his team has put together quite a portfolio of partners, and it was really important to us. I hope it's important to you as well. I hope the team continues to keep doing that and growing that list of partners. And thank you very much.
Wow, IoT and a light switch, which you can talk to. So that's really the start and birth of ambient computing, if you like. Just wanted to show what is now possible and at what points you can do that. And I think the most important for me was what Sean was saying is the speed in which companies can do this now, from 0 to market in 4 months. Think about it, what you can do today with this type of technology. It's really changing your businesses. All right. One more thing, because if you have now all of these light switches, all of these connected devices, either in the home, or think about more constrained environments like everywhere else in the world, and you have thousands, 100,000, millions, and tens of millions of them, managing those fleets is actually pretty difficult. And that's why we built AWS IoT Device Management. It organizes your fleets. It has something like fleet indexing and search. You can have fine-grained logging on top of that. And then you can have jobs and over-the-air updates all managed from device management. But one thing what we figured out with our customers is these devices are everywhere, not only everywhere dispersed geographically, but sometimes they are behind firewalls or private networks so that you can't reach them. And what is that? If you have a device which is very expensive, somewhere in a factory or somewhere behind a firewall, which you need to access because you want to maintain it. And that's why we launched last week a secure tunneling feature for AWS IoT device management, which allows you to establish a secure connection, which is called a tunnel, between two devices, even when they are behind firewalls or on VPCs. And the trick how you do it, you use the cloud as the intermediary. And you do this by establishing trusted connection between the two so that you can now, on distance, have access to those devices as if you were sitting directly next to them. And that feature is, for example, used by Thermo Fisher Scientific, which builds really complicated machinery in the medical space. And particularly when they wanted to service them, so far they always had to drive there and log onto the machines. And now with secure tunneling, they can do this remotely, which you can imagine, of course, is not only speeding up the process significantly, but also reducing the cost drastically when it comes to serving those devices. So again, additional capabilities that we built because IoT is such a diverse sector of use cases and devices, whether you go from consumer device like light switches, like heavy medical equipment behind firewalls. With that, I would like to go now to what I would almost call the holy grail of IoT. Why do you put software on devices? Why do you connect them? Why do you manage them? You do that because you want to get something out of the data that they provide to you. So how do you make sense of the data that comes from IoT devices to have intelligent actions for your business to advance? That's why we have built AWS IoT Analytics Services. And you have those questions here to figure out, okay, how do I track this value? How can I detect changes across my systems? How can I have automatic actions? Or how do I build these applications if I don't really understand intricacies between different protocols and if I don't want to do that? That's why we built these 4 different types of services, which have all been in GA, apart from Sitewise, which is still in preview. And IoT analytics, you ask, why do I need specific IoT analytics service? Why can't I use business intelligence? Because the data that comes from IoT devices is intrinsically different from BI data. It's not coming with a structured data formats from a few sources with a lot of data. It's typically unstructured data, which comes every now and then from millions and millions of sources. It's binary, very often without context, you need to enrich it. It's noisy because it comes from physical machines. So there's a ton of pre-work that you need to do before you can actually do the analytics. That's why we have AWS IoT Analytics as a service. Then, if you want to have complex business logic, which is not just simple if this, then that, but much more complex, where you can have thousands of inputs, where you need to have state notions. Think about programmer logic controllers at steroids in the cloud. That's something which AWS IoT Events does for you, so that you can automatically detect state changes or situations and take automatic actions. Or, what I aforementioned, if you want to build applications without that you need to worry about, okay, what's this protocol again and that? Because ThingsGraph is abstracting the intricacies of the different device types and even web services that in a graphical UI composer, you can combine them and then deploy those as applications both in the cloud or at the edge without knowing the details. And the one service I want to dive deep into is Sitewise, because we built Sitewise particularly for the industrial use cases. And I want to give you just first a little insights in why we put specific effort in industrial IoT. Because industrial IoT is nowadays transforming many industrial use cases across all of those different applications. The problem is, most companies can't make use of their data. It's generated locally, whether it's in a mine, whether it's in a site, or in a field. And because they don't have processing capabilities, it's just wasted. So it's like you were drilling for oil, and the only thing you do is spill it. It's the same for data here. So there was a really big need to figure out how can we help our more industrial customers to make sense of their data. And first of all, it starts with a big question: how do I get that data out of my localities, out of my facilities? And once I get it out, how can I work with that? Because I'm not necessarily just interested in an individual sensor stream come from a machine. I'm much more interested in the state of the machine. So multiple sensor data combined. I need to model my machines. I'm most likely more interested in metrics like overall operational efficiency or equipment efficiency, OEE, which is the standard term of understanding how good your machines or processes work. And all of that you need to build. And that's exactly what Sitewise does. Sitewise comes with a Sitewise gateway software, which is based on Greengrass, which you can have on a local gateway on your local OT network, which speaks OPC UA, gets all of the data out of your OT networks, puts them by the hundreds and thousands streams into the cloud. You can tag each individual of them. You can then model your assets in Sitewise, and then you can have automatic processing, what we call processing on top, for your equipment efficiency, so OEE calculations or any other metrics you want. And of course, it also stores it in the appropriate time series databases, which is very different than just putting it into S3 or any other blob storage. And developers really love Sitewise, particularly in the industrial sector now. And you can model your assets, you get your data in, and you configure all of this by the AWS IoT console. But then the customer said and say, so what? Now I get this all into my data lake, customer X. How can I expose this knowledge now to my non-developer employees? How can I go to the industrial expert, the operator, somebody in the field, and make all of this goodness and this insights now available to them wherever they are, anywhere in the world? So it's literally the question, how can I give anyone in my organization quickly get insights into my operational data? And I'm very proud to announce that yesterday night, we launched Sitewise Monitor for AWS IoT Sitewise, which allows you to create a fully managed web application for visualizing and interacting with your operational data from your device and equipment connected to AWS IoT. In that sense, it's our first offering for a non-developer user, or if you like some acronyms, it's the first SaaS application, so software as a service, that we as AWS IoT offer our customers. You really can now set up, without writing any line of code, your own SaaS application as an IT administrator. It will then automatically populate with all of the models that you have created in Sitewise. And you can get access to those type of insights via dashboarding to anyone in your company, because it works with AWS single sign-on, so you can use your own authentication mechanism, like when you do it in your enterprise network with your password and login. And to show you how it actually looks, this is how Sitewise Monitor looks. So a process engineer can just drag and drop the metrics and the properties that they want. You can then show, okay, I want to have the differently. And the moment you click, you see the live data flowing. It's immediately live and immediately works. And if you want to go and dive into your assets on the left side, then you see all of the assets which have been created, all of the different hierarchies to see what's actually ongoing. And if you can't see it on the top left corner, it says your logo here, because it's purely and truly a SaaS application. You don't see that this is an AWS application. It has your own look and feel. It is in your own namespace of an URL, and it's accessible via your enterprise account. So Sitewise, our first fully managed web application to get the insights wherever you are, as long as, of course, you're in your corporate network. And one of the users of Sitewise that we have is now Woodside Monitor. Woodside is one of the, if not the largest, natural gas producers in Australia, and they're going to use Sitewise now in all of their processing units to get their operational employees more insight into what's the state of their processing units. So I've shown you now the IoT virtuous cycle, and I've explained to you a little bit, and I know it was fast, a lot of the services that we have in software, both in device software, both in connectivity control services and also our analytics services, so that you can now know the state of everything in your assets, in your realm, and reason on top of them, even if you're not a data scientist and an expert. And it's my great pleasure to have one of our biggest customers currently, which is taking benefits of the full suite of AWS IoT, which is called Volkswagen, or VW, which is the largest car manufacturer in the world. And they set out on a road with us, AWS, to build what they call their industrial cloud, with a goal to significantly improve productivity. And it's my great pleasure to welcome Frank Göller to the stage, who is the head of digital production at Volkswagen. He's enthusiastic to taking his 122 factories across all of his 12 iconic brands. And Frank, you told me you call yourself not a cloud native, but you're really enthusiastic about lean and learning. So let's enlighten us what you guys are doing with all of this technology.
Absolutely.
Welcome, Frank.
Right. Thank you, Dirk. Welcome. Wow. That's an audience. Thank you for being here. That's my first time with reInvent, and I'm really thrilled to tell you a bit more about the digital journey we are going through in the production of Volkswagen Group. But before I talk about that, I want to share with you a short video. Please enjoy. Yeah, that's Cedric, a level 5 car concept. And Cedric is a symbol for the two challenges the automotive industry is heading for. First thing is the level 5 driving. That's definitely a challenge we have to cope with. And the second thing is emission-free driving. Also, that will push us in the next years. Yeah, and it's not only talking about products, but Cedric could also be a symbol for production, because production has also go through a big change of paradigms and new settings. And we in production in Volkswagen Group, we have thought through several strategies. We have thought about what will happen in 20 years. What is the production look like in 2040? And we have created 3 scenarios, and I want quickly to introduce those scenarios to understand what we are talking about. The first scenario on the left side, we call it blocked access. If you take today's situation, we talk about America First, we talk about the Chinese Belt and Road Initiative, we talk about Brexit in the European nation or European Union. And if we take this in account, it could happen that the regions and countries isolate them even more. And there is no global material flow, product flow between those regions. So it could happen that the whole global supply chain we are living with at the moment is not working anymore. So a big change for our production network. So that would be one scenario we have to cope with. Another scenario in the middle, we call it ecolocracy. If you take the Fridays for Future, if you take the whole decarbonizing discussion at the moment, and we think that this is even a stronger topic in 10 and 20 years, then we as a producer, we have to think about loops. That means producing a car, running a car, taking it back after usage. What do we do with the old material, with old components, with old batteries? That's also a new concept for us we have to think through in production. And the last scenario we also thought about is the so-called virtual titan scenario. You know Amazon for sure. You know Google. You know Apple. If these companies grow more and more, get more and more market power, we have to ask ourselves, what is the value of our brands? Maybe do we become a no-label or a white label producer? Do we produce our products only for these big virtual titans? I don't know yet, but that's definitely a question we have to ask ourselves and to think about that, what we have to what we have to do at the moment. The good thing is that one commonality in those 3 scenarios is the digitalization. We are absolutely sure that digitalization of production is a key topic in all of those strategies, and therefore we have to think about to bring this into our organization. And if we talk about our organization, do you have an idea how many people work in our production processes, in our production factories? It's around 300,000 people producing cars, planning cars, planning processes, and that's a big, big number. And the very important thing is that they understand we are coming from an old world of a VW Beetle. Maybe you know that car. Today we are introducing the new ID family, the ID3, for example, in the middle. And maybe Cedric is a placeholder for the future products coming up. But this is something we have to discuss with our colleagues, because they have learned the Beetle style, the old Beetle style. And now we have to tell them about the roadmap we want to go with them. And the roadmap for us has 5 very important steps. Those steps are starting with the connectivity. Creating connectivity is our very, very first thing we have to do. Then we are gaining or creating information, creating knowledge out of that information, and then maybe we step into prediction and also into autonomous systems. But this is maybe obvious for you here in this room because you work with these topics day by day and for several years, but not for our people. Our people, they really are more in the steel, in the bits and bolts and in the screws, and therefore it's so important to spend a lot of time in communication and talking about the new steps and the new activities we have to look for. Yeah, and why is it so important? Because our old thinking is based on a very old style IT architecture. It's a hardwired point-to-point architecture we've got mainly in our system. What does this mean? In the past, the problem was coming up. People talk about, oh, how can we solve it? What can we do? And then they said, yeah, let's do a wire from point to point. And the next problem, point to point. And out of the sudden, we have structures like this, huge monolithic systems with lots of databases, with redundant data in those databases. The databases are not talking to each other. Exchange between the databases is only possible with non-standardized interfaces, very often manually, data into Excel, modified into Excel, go back into the data file, into the database. This is, I want to say, our common state at the moment. And therefore, we have created a true north picture. This true north picture is driving us together with the colleagues from AWS that we have two very important elements. One is the digital production platform for ourselves, and the second is the industrial cloud. Let me talk about what is behind that. Digital production platform means we have 122 factories. 122 factories all around the world. And the idea is it would be brilliant if those 122 factories can collect their data in all the separate processes together in one cloud, in one database, and we can use those data to learn and to see what kind of improvements are made in America, what can we use in China, and what is applicable in Germany or in Europe. So having a joint database, having the chance to scale, to be scalable with the applications and the solutions, and building that up with the help of the services from AWS is the first step we are doing. After achieving this, after having this structure installed and seeing the impact of those applications, we say, why shouldn't we use that for ourselves? Why couldn't we use the idea of the applications, the idea of this infrastructure, not to help also other companies, other OEMs, car manufacturers, other suppliers, maybe other industries, having also some impact using this structure. Therefore, we are creating the second industrial cloud so that we can offer our knowledge we are jointly creating at the moment also to other partners and companies. But going back to the digital production platform, how is it organized? Very often we talk about layers, also we do it here, and we have three main layers I want to introduce here. You see the yellow one, and Dirk also talked about that, connectivity. Connectivity is so important, and we have managed to organize now several standards to use standard tools from AWS to bring up to 90 machines in the first year into our cloud, to use standard interfaces, to use standard gateway structures to really bring in unstructured data into the cloud. And honestly, I do not know how loud is our data, but I think our data is also very noisy. Having that done into the yellow layer, then we go up into the blue one. And here, definitely, the standard tools and applications from AWS is helping us to structure it, to prepare the data for usage. But very important, we have also own VW systems or in the brands. Therefore, we have to merge the AWS logic with our systems because it's clear that we cannot start from absolutely new, and we have to embed the activity, the software and the applications into our existing system. So this is then the core, the spine of our platform, and based on the blue and the yellow layer, now the impact layer is coming, the green one, because here we build up a marketplace. The idea is scalability first, have standard applications, and to use those standard applications to help maybe 10, 20, or 30 factories with the same problem. In the first year now, we have improved press shop productivity. We have measured OEE, overall equipment effectiveness, to really understand how well or not well our machines are running. This structure is now established, and we know that the DPP core is working. 2 factories are working with it now. It's a very tiny piece, but using Outpost, using Greengrass, using Sidewise is definitely driving us. And we know that the minimal viable products we have installed now are scalable, and we can use it now in the coming year and next year with additional 15 factories. So that means we have a plan to onboard another 15 factories to really scale the learning effects from this year. And also, we want to work more intense with external partners to build even more applications we can use in our factories. It's so important that we invite partners and application developers to join us to really think about problems coming up in our production and to build a standardized application. But it's not only a standardized application in the marketplace, also some microservices very individually built up for individual plants can be positioned there. But this is a second step we are thinking about. That's the rollout. You see, we have 15 factories, as I have already mentioned. It's 7 brands, and please be aware, we have 12 brands in total. 12 brands means it's definitely a different culture in each brand. There's also some brands over 100 years old, and that means also we have to do a lot of communication and a lot of talking with them. What is the basics behind it? Why do we do it? What is the purpose behind it? And doing that, it's very important that we have the AWS teams with us, because they bring new innovative thinking into the teams. We work in these so-called pizza teams. I guess you know the term. So in very small, self-responsible working teams, and also in a very agile way. We have very engaged people also from our side in the VW onboarding team, also from other brands engaged here, so that we have enough energy to scale up to really have a good learning curve. But it's only 15% of our network. I mentioned it before, 122 people, and we are looking for new people. So if you're interested, if you know someone wanting to work in the automotive industry, please feel free to join us, because we are looking for people with openness. We are looking for people who are curious, and then we are pretty sure that we can change our culture of traditional car manufacturing, that we can change it to a very new and more agile way to really drive our scale within the next in the next 5 years to the 120 factories. Yeah, and finally, what are our success factors? Technology-wise, we need innovative technology delivered by AWS. We need analytic capabilities to really understand what is happening within our data. Principle, it's all around people. The principles, it's clear, 12 brands, different cultures in the brands. We have to think about the capabilities within our people, in our staff, and we have to think about training them and making them capable running in that system. And culture-wise, I only want to repeat a sentence said by Peter Drucker: in times of change, it is the biggest risk to act in yesterday's logic. So far, so good. Thank you very much.
Wow, so you saw one company doing complete new products in 4 months, another company most likely reshaping an entire industry, all using AWS and AWS IoT technology. So now you might say, okay, great, so what about me? What about my own business? How can I get started faster and very quickly? And that's why we at AWS also put together what we call solutions. You can get AWS IoT solutions which were made by AWS, and at the same time also what we call partner solutions, what our AWS partner network, in short APM, partner networks built as solutions which have been pre-vetted. And they're tackling many different types of use cases and across industry. And we put down together a single place where you can get to them. You see that there, the little link, awsamazon.com/IoT/solutions, where we have both the AWS solutions as well as our partner solutions accessible for you. Typically, the AWS solutions help you start being quicker because we have CloudFormation templates, which very often you can just deploy with one click. They have reference architectures, GitHub repositories, how-to deployment guides. We have solutions for real-time device monitoring. ETL means data extraction, transformation, and loading use cases. Machine learning and inferencing in the cloud and at the edge. IoT device simulators, camera connectors, machine-to-cloud connectivity. So a diverse set of different solutions, and I wanted to have one which I dive deep, which is what we call our connected vehicle solutions. You can go down and you see there, connected vehicle, click on this and figure out what it does. And the idea here was that it allows automotive companies in very short time frame build up applications that access securely data coming from their cars. Here the devices are cars, whether it's telemetry data, put this into the cloud and build them application on top. Like, for example, one of our customers is Avis, who is doing this by having now built their solution detecting anomalous behavior in vehicles, diagnosing issues. They can create driver safety scores and enable location-based offerings, all based on the connected vehicle solution. And we're a little bit proud as well that we have been ranked as the #1 cloud platform for connected car solutions out of the ABI research just last month. So that's just one. Another one, very different, connected home solutions. Here again, this is much more about home automation, home security, home monitoring, or home network management. All of these very different applications. And I mean, you have just seen one of our customers today with iDevice, what they do. But if you want to get started quicker and faster, there are solutions for you how we can get started in almost no time, and quite good customer testimonials as well, for example, from Visio, who used this to start and build their own solutions. And again, don't take my word for it. We have again won apparently an award. It was the best platform for connected home and consumer solutions by IoT Global. That was just 2 months ago. But I talk, it's not only our own solutions, can be also our partner solutions. And here the same thing. Start from the same starting point, figure out what our partners do. They have a variety of different offerings which you can use, typically coming out, then not necessarily also from CloudFormation templates, but you can also go to what is called our IoT marketplace and to the AWS marketplace, where you have more than hundreds and hundreds of solutions in the IoT space that you can immediately deploy and start working with. And one of the partners I chose is Isla for their connected home solutions. That's to show you don't have to rely on AWS solutions. You can also use a third party, because Isla really has great experience in building those in the commercial and in the consumer goods. And apparently our partners are also pretty good, because Isla also won the IoT Company of the Year Fast 50 out of Deloitte's Technology Fast 500s. So a ton of solutions which you can deploy and find out of one single part. But that's all good, you might say. But IoT might be even more complex. What if those solutions are not good enough for you? What if you need to do different things? That's why we built what we call our APN, Amazon Partner Network. And particularly in IoT, we have our IoT Partner Network, where we cluster our partners into multiple different categories. Let's start with the edge. So whether you're looking for chipset manufacturers, OEMs who manufacture finished goods, contract manufacturers, we have a partner for that. You want a silicon supplier. We talked just before about NXP, who had this AVS integrated, or Qualcomm, which is somebody else for AVS, for IoT Core. We work with most likely almost all of the chipset manufacturers in the world. You talk about connectivity. You want to buy your gateways, Technicolor, Airtest. Name your favorite gateway manufacturer. AdLink, we just talked beforehand. You want to have a network or a carrier which does you the network connectivity. Or you want to have what we call an independent software vendor, like the Isla means of these worlds, which just has the additional technology that they bring into fruition, paired with what AWS does in a certified manner. Or you want to have additional resources with additional capabilities, which we call our system integrators. And we have both local system integrators for your local needs, or global system integrators, depending whether you're a global company. Last but not least, very often customers ask us, okay, but where do I find the devices? Because I'm not a device manufacturer. I'm not a device company that just works with AWS IoT. Can you give me a little bit of insight into this? We have what we call an AWS Partner Device Catalog. Again, devices, Amazon, AWS.com, or from the IoT homepage, where we list all of the certified devices that we have with our partners checked and that they work out of the box with AWS and AWS IoT. And that starts from development kits and almost chips for or components if you want to build your own devices, but also goes into finished goods, whether this is gateways, sensors, or cameras. So the choice is always a selected hardware, curated catalog from our Amazon Partner Network, and it can help you roll out your solutions much faster. And you can also purchase all of those devices directly from our partners. We always have the purchase those devices link. And you can filter device types and geographics or type of usage. And here, for example, it was just give me Intel-based devices. We have an ever-increasing number of those devices because every month, every day, we actually add additional devices for you to figure out, okay, what is the device base for my IoT solutions? With that, I'm coming close to the end of our presentation today. Today, I hope I brought it a little bit more clear to you that we as AWS and AWS IoT have the broadest and deepest functionality. Andy today talked about the broadest and deepest functionality in the cloud. The same is for us at AWS IoT. You have seen what we do on the device software side, connectivity and controlled services side, and the holy grail of analytics and looking at data. You saw a new announcement that we had with Greengrass with Stream Manager container support, AVS for IoT, our secure tunneling, and even the Sidewise Monitor for a SaaS application. You have seen the spectrum of what you can do and solve with this type of services today, even on stage with iDevices and VW for this virtuous cycle. I haven't talked a lot about multi-layered security apart, a little bit of Device Defender. That's our proprietary zero, whatever we do, whether it's our integrated authentication, authorization, and policies for IoT Core, whether it's our code signing for device management, our PKCS support for FreeRTOS, whether it's the Stream security implementation that we have for Greengrass, or Device Defender as a service. Never forget about security. It's our proprietary zero next to the other proprietary zero, which is scale. Proven experience at scale. Again, we don't talk about a few 100,000 devices. We build everything serverless. You go with our services, you don't have to manage any infrastructure. You start with 100,000 devices, you go to 1 million, you go to 10 million, you scratch the 100 million mark, we handle that for you. And if you scale down, we scale down automatically for you, and of course you only pay for what you actually use. And last but not least, I hope I was able to bring to you also some of the solutions directly with our partners and customers, but also with the AWS solutions, our partner APM solutions, our partner network, and our device catalog. With that, I would like to invite you, if you want to learn more, to visit all of the other Chalk Talks or deep dives that still happen during this week here at re:Invent. Please visit any of those specialized sessions to get the deep dive. You can, of course, go to our homepage, awsamazon.com/IoT, to learn more. And I would also like to thank all of my co-speakers, namely Sean Monteith from iDevices and Frank Göller from VW. And of course, last but not least, I would like to thank you for your patience. Listen to me for almost 1 hour. And I would just like to close with one ask to you. Now that you know and can know the state of everything and can reason on top of that data, what problems will you solve? Thank you very much and have a great re:Invent 2019.